Hello everybody, and once again welcome to Pankaj Sir Echelon Tutorials. And in this today's session we are going to continue with our numericals on limiting reactants. Okay, so I've made a couple of videos already on this limiting reactant, and I've made you understand the concept of this limiting reactant and the excess reactant. And we have solved one numerical as well. So in continuation to that, today we are going to solve one more numerical on limiting reactant. So here we go, and this is that question. Question number one, this one. Okay, it says that zinc reacts with aqueous hydrochloric acid to produce hydrogen gas and zinc chloride as. Okay, now these are the three scenarios, right? In scenario A, 12 atoms of zinc are combined with 8 molecules of hydrochloric acid, right? In scenario B, 3 moles of zinc is combined with 4 moles of hydrochloric acid, right? In scenario C, 40 gram of zinc and 56 gram of hydrochloric acid are combined to form this hydrogen gas and zinc chloride. Now the question here is for all or for each of these three scenarios A, B, C, you have to find which is the limiting reactant in each case, right? So let us get started. So the chemical equation says that zinc is reacting with aqueous hydrochloric acid to give hydrogen gas and zinc chloride. So first of all, we'll have to write a balanced chemical equation of the same. So the balanced chemical equation is this one. Okay, so it will be Zn plus 2HCl will give you H2 plus ZnCl2, right? And it is very much balanced. Once the equation is balanced, you have to write the stoichiometric coefficients of each reactant and the product. So the stoichiometric ratios or the stoichiometric coefficients for zinc it is 1, for hydrochloric acid it is 2, for hydrogen it is 1 when there is nothing in front of the the substance, you have to write 1 over there. And for zinc chloride also there is 1. Okay. So the ratios, the coefficients are 1, 2, 1 and 1, right? Now let us first start with scenario A. Okay. In the scenario A, 12 atoms of zinc and 8 molecules of HCl are combined. So zinc is now you have to see which one is limiting reactant. See, either one can be limiting reactant, either zinc or hydrochloric acid. Now you have to decide on that only. Okay. So to decide on that, we will need this particular formula, that is limiting reactant constant K is equal to number of particles divided by stoichiometric coefficient. So for zinc, you will have to find out this K, and for hydrochloric acid, you will have to find out this K. So for zinc, if you want to find out the K, then the value will be K for zinc will be, now how many particles are there? There of zinc there are 8 at 12 atoms. Okay, so I'll take 12 divided by the coefficient, stoichiometric coefficient of zinc is 1, so 12 upon 1 I'm getting K as 12. Same way K for HCl, I will get 8 molecules are the number of particles. So 8 divided by the stoichiometric ratio of hydrochloric acid is 2. So 8 divided by 2 works out to 4. Now out of these two K values, which one is smaller? Of course, 4 is smaller. So the substance corresponding to this smaller value, which is hydrochloric acid, has to be the limiting reactant. So it is decided that hydrochloric acid is the limiting reactant. And if hydrochloric acid is the limiting reactant, obviously the zinc will be the excess reactant in this particular reaction. So question number 1A has been sorted out. Okay, so in A, in scenario A, hydrochloric acid is the one which is your limiting reactant. Now let us check for scenario 2. Now scenario 2 says that 3 moles scenario B, you can say. Okay, B says that 3 moles of zinc combines with 4 moles of hydrochloric acid. Okay, so now again the formula will be LRC, that is the limiting reactant constant K, will be equal to number of moles upon stoichiometric coefficient, isn't it? This formula we are going to use, right? So the number of moles for zinc is given as 3. So zinc, LRC for zinc will be 3, because 3 moles of zinc are given in this reaction, divided by 1. 1 is what? The stoichiometric coefficient of zinc. So 3 upon 3 is equal to 3. Okay, so you get K value for zinc as 3. Similarly, K value for HCl will be 4 upon 2, because 4 moles of hydrochloric acid are used and the stoichiometric coefficient of HCl is 2. So 4 upon 2 works out to 2. Out of this 3 and 2, which is the smaller value? Of course, 2 is the smaller value. So the 2 is corresponding to which reactant? Hydrochloric acid. So again, this hydrochloric acid will be the limiting reactant, because the K value for hydrochloric acid is less than the K value for zinc. So here again the limiting reactant is hydrochloric acid and the excess reactant is of course zinc. Okay. Now let us check for scenario C. Scenario C, 40 grams of zinc is reacting with 56 grams of hydrochloric acid. Here you will have to be careful, because here these are not particles, these are not moles, these are mass. Okay, so when mass is given, then mass should be converted into moles, and then you have to use this formula, number of moles upon stoichiometric coefficient, right? So for zinc, the number of moles can be calculated. Now, number of moles N is equal to, when mass is given, this is the formula. Number of moles is equal to mass in grams upon the AR or the MR. Okay, that is relative atomic mass or the relative molecular mass. Okay. So for zinc, if you want to find out, okay, then see, first I'm trying to show you the wrong way. See, in a hurry or in a lack of knowledge, you may go this way. For zinc, you may go to find out K by taking 40 gram divided by the stoichiometric of zinc, which is 1, 40 upon 140. And for hydrochloric acid, you may go for 56 upon 2, which is 28. 40 and 28, out of these two, 28 is the smaller number. So you may rush to say that, okay, this is a but this particular HCl is your limiting reactant. No, but this will be wrong thing. See, I've put a wrong over here, right? This is a wrong method. Why? Because we are considering directly the gram. We should not consider the gram. We have to consider the mole. Okay. So the proper way will be, first convert the gram into mole. So mole of zinc will be how much, that you will have to first calculate. So I have done this calculation here. N of zinc, that is number of moles of zinc, will be equal to mass of the zinc in gram divided by the AR of zinc. So mass of the zinc used is 40 grams. So I'll write here 40 gram divided by AR for zinc is 65.39, and 40 divided by 65.39 works out to 0.612. So the zinc, the mole N for zinc I am getting as 0.612. Same way, I'll go for calculating the number of moles for hydrochloric acid, which will be given by mass of hydrochloric acid divided by MR. This time it will be MR, not AR, because hydrochloric acid is a compound, not an element. So mass of the hydrochloric acid given is 56 grams. That divided by the MR of HCl is 36.45. And 56 upon 36.45 works out to 1.536 moles. So N for HCl you are getting as 1.536. Now once you get the moles, now you can go ahead and find out the K value. Now the formula is K for zinc will be equal to number of moles of zinc divided by the stoichiometric coefficient of zinc. Okay. Same way, K for HCl will be number of moles of HCl divided by stoichiometric coefficient of HCl, okay, of zinc. Now this is number of moles. Just now we calculated for zinc, it is 0.612. So can I write 0.612 divided upon stoichiometric ratio, coefficient of zinc is 1. So this K value for zinc I'm getting 0.612, right? Now K value for HCl will be 1.536 because that is the number of moles divided by 2 because stoichiometric coefficient for HCl is 2. Now this works out to 0.768. Now out of these two values, which one is smaller? Of course, this is smaller. So your zinc is the limiting reactant. In the C scenario, where the grams were involved, okay, the zinc has become the limiting reactant, and obviously when zinc is the limiting reactant, then your HCl is your excess reactant. So you can see that in the A and B scenario, in both that scenario A and B, hydrochloric acid was the limiting reactant and zinc was the excess reactant. But in scenario C, zinc is the limiting reactant and hydrochloric acid is the this thing, excess reactant. Okay, so now we have got a good drill and a good idea of deciding which reactant will be limiting reactant and which will be excess. Okay, and don't go by only the uh, simple ratios, okay, simple formulas. You have to go deep into that. I've given you here three scenarios, A, B, and C. In one case, the reactants were given in terms of particles, right, like atoms and molecules or ions, okay. In second scenario, the reactants were given in terms of moles, okay. And in third scenario, the reactants were given in terms of mass, okay, in grams. So in all the three scenarios, you have seen that there's a different method, different approach of coming to that K factor value, which is known as the limiting reactant constant, okay. And once you got the K value, then you can decide which one will be the limiting reactant and which will be excess reactant, okay. So all these things you have to be very careful about when doing your calculations on limiting reactants. So this was my one more video on this limiting reactant. Hope this video is also going to give you a lot of confidence and a lot of insight that in three different scenarios how the things work, right? So that's all for today's session, today's video. In the next video, perhaps I may come up with some more questions on this limiting reactant. And for today, that's all. So if you happen to like my video, please subscribe to my channel. My channel's name is Echelon Tutorials. Okay, I am Pankaj sir, and goodbye. Take care, all of you.